All right, let's get started. As I mentioned before, my name is Stephen Roth, and I'm president of CarmelSoft, a developer of mobile and web-based software for the built environment. And CarmelSoft also oversees gbXML, Green Building XML. So today's webinar is titled A Demo of Common BIM to BEM, or Building Information Modeling to Building Energy Modeling Workflows using gbXML, and also the new gbXML Validator. So today we will be demoing BIM to BEM workflows using gbXML, and also demoing the Validator, which was developed actually as part of an ASHRAE research project, specifically ASHRAE research project RP 1810. And we'll make sure to explain all of that in the webinar. So the agenda for today, I will be presenting an overview of gbXML, and then we'll conclude the webcast with some Q&A at the end. Hopefully we'll have around 10 minutes left. And then I will pass the webinar on to Greg Collins and Yu Chen of Zero Envy, and they will be demoing BIM to BEM workflows using gbXML that they encounter on a daily basis. And then after that, Krishnan Gowri of Intertek Building Solutions will be demoing the new gbXML Validator that was developed as part of ASHRAE RP 1810. So before we continue, I'd like to conduct a quick poll. So the first poll is this: what type of professional are you? And I'll show you the results after everyone makes their selection. Okay, looks like everyone made their selection, and I'm going to share it real quickly. And it looks like the majority of you are energy modelers. Second is engineers. A fair number of architects, which is great. Other and software designers. So about the allocation that I expected for this type of webinar. So great. All right, let's move on. So before we delve into the actual demos, I do want to give everyone an overview of gbXML. So I realize this will be a review for the majority of you. However, there's always new people entering the industry, which is great. And so I like to make sure that everyone understands exactly what gbXML is. So I like to call gbXML the language of buildings. It allows disparate building design software tools to all communicate with one another. So, as part of its national infrastructure plan, the current administration has set a goal to retrofit 2 million commercial and residential buildings over the next 4 years. So energy usage and energy auditing data for these buildings need to be stored in a consistent manner to help achieve this aggressive goal. So this means data interoperability is more important than ever. And gbXML is one of those data interoperability schemas that can aid in this process. So what is gbXML? Well, think about building information modeling and gbXML. They're complementary to one another. The whole essence of BIM is interoperability. You want to get the data out of the BIM and into other tools that can utilize that data. So think of gbXML as the transport mechanism that allows this data to flow from your BIM authoring tool to external tools and back. So gbXML is not a programming language, nor is it a software tool. It's a structured XML schema or language that focuses on storing data about buildings. And it's all in the name of helping architects, engineers, energy modelers design more energy efficient buildings. And it accommodates many types of analysis, not just building energy modeling, but whole water use, carbon emissions, heating and cooling, load calcs, renewable energy, HVAC equipment sizing, lighting analysis, CFD analysis, fire analysis, and more. So it can accommodate many types of analysis related to building design. So a little overview of what gbXML, Green Building XML is. Like I said, it's an open source schema available at gbxml.org and also on GitHub on Green Building XML. Includes a board of directors comprised of 11 BIM authoring and building analysis software vendors, which you can see on our website. 54 software applications support gbXML throughout the entire world. And in fact, gbXML has been around for 21 years. It was founded in the year 2000. And several research projects are currently focused on improving the gbXML workflow, which we will talk about in more detail later on. And there's also a free online gbXML viewer, which we are constantly updating, and it is available at gbxml.org by clicking the viewer link in the upper right-hand corner. So ASHRAE Research Project RP1810. I'm not going to go into too much detail about this because Krishnan will be talking about this in much more depth, but this is an overview of it. It's the development of reference BIM test cases for improving usage of software interoperability schemas. Quite a mouthful, but basically we developed a bunch of test cases for simple geometries exported from your BIM authoring tool to validate them. And we've developed not only the documentation for it, but also a website. And those will be demoed by Krishnan and his team in a little bit. Also, there's another research project, which actually my company, CarmelSoft, has been working on for the past 10 months, titled Innovative Building Energy Rating Delivery Models. Now, this deals more with another schema called Building Sync XML, which deals with energy auditing workflows. However, we also have incorporated some validation and also the viewer into this tool for gbXML. I'm not going to talk about this in today's webinar, but in a future webinar, we will be discussing this. I briefly mentioned before our free online gbXML viewer available at gbxml.org. We call it the Spider Viewer, and it's available on our website and also on GitHub. It's a great way to open your gbXML file, view the model, pan, zoom in, zoom out, select specific elements to query them. And you can also edit the model too. So it's pretty powerful and it's all within your web browser. There's no need to register or anything like that. And it's pretty fast too, even for larger models. So I like this graphic here, and you've probably seen this before in other webinars, but I want to talk a little bit quickly about what are semantics. Well, semantics is the study, is the meaning of language. For example, destination and last stop technically mean the same thing, but as students of semantics analyze their subtle shades of meaning. And so as it applies to interoperability, the same element in a schema that exists in two different schemas may actually mean two different things. Or a software tool that imports a schema may interpret an element in a different way than what was originally intended. And as you can see, there's many different types of interoperability schemas out there, not just gbXML. I'm sure many of you are familiar with IFCs, and there's, of course, Building Sync XML, Haystack, Brick, and others. So these are kind of a breakdown of how the different schemas aid in the whole design to maintenance life cycle of a building. All right, so let's get started with the demo. First of all, I would like to introduce Greg Collins. He is the founder and principal of ZeroNV, a consulting firm that provides expert energy modeling and building performance analysis for new and existing buildings. Also, Yu Chen will be helping out with this demo. He is a building performance engineer with ZeroNV and has been working in the energy modeling field for 6 years. So I'm going to pass the webinar over to Greg now. Greg, you should have control.
All right, hello everybody. Working on sharing my screen here. Is that showing up, Stephen, the slides?
Yes, it is.
Perfect, okay. Thanks, Stephen. Hello everybody. So I'm gonna provide just a couple slides, just give you some overview context about kind of where you and I are coming from with our workflow. And then I'm gonna turn it over to you, and actually we're gonna play a pre-recorded demo that he put together that actually shows one of our real projects in our Revit model gbXML workflow into our energy simulation software. So this part will be quick, and then we'll get into the fun stuff. So our firm does building performance analysis and consulting, you know, because we feel strongly that the best buildings have the smallest footprint. So we do this. Most of that work is energy modeling. Most of our work is new construction. We do some existing building work as well. So the slide that Stephen showed with the different kind of life cycle of the building and different, you know, data formats that building data lives in, you know, hits close to home. And I took a screenshot of that, Stephen. So I'm going to dig into some of those things a little bit more later. But anyway, so I'm going to show you. Well, what I'm going to show you is just kind of high level of the workflow. But you know, we didn't invent this workflow, or I didn't, and you didn't. It's something that I learned at the first MEP engineering firm I worked for out of college in 2009. So in around 2010, I was using a very similar version of this workflow, but over the years, we've definitely refined it and it's evolved. And I'll show you more like high level what we're doing now. And then again, you will dig into the details a little bit more. But basically we use Autodesk Revit to build a 3D model of the building, and that's we call it the energy analytical model in Revit. So we link in the architect's Revit model, and then we basically trace it. And we could use other tools, but Revit's just designed for this, right? It's built for this, so there's a lot of things that make that software just faster. So that's what everything's about for us. All we do is energy modeling for the most part. So, you know, saving 10% on building your geometry really adds up for us. So we start in Revit. We export a gbXML file from our Revit model. And this is, so the 2010 version, this file was then imported into the Green Building Studio tool, which kind of parses that into an IMP file that we could open in eQuest and get that geometry into eQuest, which was the simulation software that I was using at the time in the firm I worked for. And then they had developed a spreadsheet tool that could kind of break down the IMP file as well and kind of replace certain things, space types and lighting power density values by space type and that sort of stuff. So that's something that was optional that we did at the time. And then fast forward to now, the Revit part of the workflow and the gbXML export, all of that is almost identical to what I was doing 10 or 11 years ago. What's new is that we've evolved. Like I've been using ISVE. I probably started using it around 2010, 2011, but that's our primary energy modeling tool now. And so we're going. We don't need Green Building Studio anymore. VE imports gbXML directly. And what I'm showing on the right side is just a snapshot of the navigator in VE. So IES has been working on developing different tools to help you clean up, identify issues, heal different geometry issues, and things like that. So that workflow has improved, and the tools supporting it has improved a lot. And then we're still kind of coupling IES software, the VE software, with spreadsheets, and then using Python and the built-in API to kind of leverage things as well. And we're using, like, gbXML can define the entire building, like all the information you would need, not just geometry, but space types, lighting, power. I think recent updates have even made more progress in defining full HVAC systems. So we always use it for geometry. Sometimes we use like more of that data, but VE is built to, it defines things a little bit differently, and sometimes it's just faster to do something in this software. So this is all about speed and efficiency for us. So we kind of we leverage parts and pieces a little bit differently. So just, showing some pros and cons. So, there are way more pros and cons in my opinion, but it's consistent and it's efficient for building geometries. So you can, learn that workflow, and then it's very powerful. You can use it for lots of different applications. So the interoperability of gbXML is great. So you have your geometry, and you can import it into VE, you can import it into eQuest or a ton of other software tools. So if you want to do energy studies here, daylight analysis here, you could do that. And then I think the third big pro for us is that by learning Revit, Revit is where a lot of design happens, especially on the non-residential side. And so, we have access to a lot more information, and we can kind of pull open an electrical engineer's model and, get all of our lighting power directly from Revit. That's a whole other kind of workflow, and it has its own issues, but like once you have access to that model and that information and know how to get around it, it's a lot easier for us to kind of extract the information we need. Some of the downsides are, Revit is an expensive license. So if you're just an energy modeling firm and you're not designing in Revit, then it is cost prohibitive, or it's, I don't know, harder to kind of realize the overall payback, I guess. There is a steep learning curve in learning any software tool, and then also in you can't just know how to do Revit and know how to build the model. Like, it's a very specialized, specific way to build the model, the Revit model for this purpose. So that's a steep learning curve. But again, this has been done for a decade, and there's lots of presentations and YouTube videos and material out there. So it's easier to learn now than it ever has been. And then we still run into issues sometimes. I'd say the biggest one is, when we're getting into Energy Plus. Energy Plus is a little pickier about certain geometry issues and things happening than like ISVE is. But I'd say overall it's beneficial for sure. And then just some things that I'm excited about working on more is just more automation built into this like data workflow. So using Dynamo within Revit, doing scripting on the XML file directly. We're starting to build scripts that can just parse the XML and change window dimensions in the 3D geometry, for example. And then we're doing a lot more, like, I don't know, every week we've got a new tool built in VE's Python API. So that's kind of the tail end of this workflow, but still a lot to be leveraged there. And things we're looking into doing, or that, I don't know, I'd love to see done maybe in the Spider viewer, is some cleanup of the geometry. So I put an example of rounding vertices, because sometimes, like, the Energy Plus issue that we get a lot is like, you get an error about this surface only has 3 vertices, and that's illegal. And then you scroll up and there was a warning about this vertex is too close to this one, so we removed it. So things like that, if there was some kind of massaging of points that could be done, I think that would streamline things quite a bit. Just one example. And then I know some firms are doing this. We're not really doing this, but this workflow can be two-directional. So you can, get your geometry and your building data into your analytical software, run load calcs, run a simulation, and then push that data back into Revit for design. We don't do mechanical design, so that's why I'm kind of calling out the mechanical engineers here, and I've seen some using it, and I think that's super powerful. So if you are a mechanical engineer, I think this has, like, I don't know, way more value to you. That's all I wanted to show today. So here's I'm going to play the video, so we're not done quite yet, but here's my contact info and use. So feel free to reach out if you do have questions. And I will say real quick too, one of the things I wanted to mention is you know, building the geometry is like a big part of the energy modeling process that is easy to kind of carve off as well. So we've actually been starting to build geometries for clients. We don't usually use Energy Plus, but we just built, you know, an energy model geometry or gbXML geometry for a client so that they could do some simulations in Energy Plus. And the spider viewer is awesome because it gives them and you a way to, like, you know, open the model, view it, kind of interrogate it, and they can look at the quality of the model they're getting. So that's something that's, you know, I think newer and kind of cool and exciting. So let me stop sharing my screen. I will play the video.
Hi everyone, my name is Yu Chen. I'm a building performance engineer at Zero Envy. In this video, I'm going to show you an energy model geometry. Hi everyone, my name is Yu Chen. I'm a building performance engineer at Zero Envy. In this video, I'm going to show you an energy model geometry we created for one of our projects in the past. I mainly wanted to show you the workflow and also how convenient it is to use Revit to create the geometry for energy modeling purpose. Let me walk you through it. So what you're looking at here is a high-rise residential building, and it's about 27 stories. I will just rotate around to show you how it looks like. As you can see, this building is huge, and it's the geometry is pretty complicated, and you can imagine how long it is going to take if you were to use an energy modeling software to create the geometry from scratch. So that's why we use Revit. So the way we created this model is by linking an architectural background into this Revit file so that we can trace everything and basically create a simplified version of this architectural model. So this is the architectural background. And because this project has got two buildings, we were only focusing on phase one, which is this building only. So you don't need to pay attention to anything that's going on here. And yeah, if you go to a floor plan, you will be able to see an architectural floor plan as well. So this is where everything starts. We basically started by tracing exterior walls on level 1. And once that's finished, we will do the internal partitions. And you can also place windows, door components. And these are door components, but we're using them for something else, and I will explain later. And you can also see we have placed spaces here and give them names. So one thing I wanted to say here that is really helpful of using Revit is if you have typical floors, you know, if the next few floors have the exact same footprint and layout, what you can do is you can basically copy everything on this floor and paste them to the levels you want to paste them to, which you can do it this way. So that is really efficient. One of the benefits of using Revit. Yeah, and let me turn this off and we can see the geometry more clearly. So I wanted to show you guys a few things here. As you can see, we have color-coded everything. So we have a Revit template. Every time when we start a new project, we will use that template to start with, and all the building components are color-coded. So, you know, for example, we are using this color to representing exterior walls, and we're using purple to represent roof. And you can see we have also been using roof components to create exterior shading. These are actually balconies. Later in the energy modeling software, these components will be recognized as shading elements as well. So in Revit, you will just be using roof components to create horizontal shading But if you wanted to create vertical shading elements, you will, in our template, you will be using this exterior shading, building shading here, and that will allow you to create a wall component, but it's going to be recognized as shading, vertical shading elements in the energy modeling software if you have like vertical things. So the next thing I wanted to mention here is these doors. So these are door components, but we are actually using them to represent spandrel panels. We want to do that so that we are able to differentiate spandrel panel from the rest of the wall. Because if you don't do that, and you won't be able to assign thermal construction to a spandrel panel explicitly, right? So this way will allow us to create thermal construction later for spandrel only and for the rest of the wall. Creating spandrel, so many spandrel panels in this Revit model is really fast. However, if you want to do this in an energy modeling software, it's going to take forever to do because you have to place each spandrel panel on each floor. Whereas in Revit, you can, do spandrel panels on one floor, and if there are typical floors, you can copy paste them, right? So that's where Revit is really speeding things up. So the other thing I want to show here is the glazing. So not only this project is heavily glazed, but also it's got many different types of glazing. If you go to a window, and here you can see we have created a list of glazing types here, and we have assigned all of them to the building. If you look at one of these glazing, and you can open its property and look at what's in there. So under analytical properties, you can see we have assigned a glazing type to it, and Revit has got a default list of glazing types that you can choose from, so that's really helpful too. So that's how you can do it. In Revit, you can just take all the windows that you want that are under the same glazing type, and you can change the glazing type of those windows. And if you were to do this in an energy modeling software, it's going to be really slow. You kind of have to go into each floor, each room, and pick a surface and assign a glazing type to the window. So again, that's where Revit is super helpful. And just to clarify, the glazing type list, the default Revit glazing type list we just saw, those aren't the actual glazing types we are going to use in the energy model. The point of selecting unique fenestration types in Revit is to make sure, having them assigned by type in Revit before the model gets imported in the energy modeling software. So we don't have to do that in the energy modeling software, which is super slow. And then we will just need to update the names and the properties in the energy modeling software as necessary without needing to reassign them again. So those are a few things I wanted to show you why we want to use Revit, especially for a big project like this, right? So the next thing I'm going to do is I will export this model to a gbXML file, and I will import that into an energy modeling software. And let's do that. You will go to File in Revit and do Export to gbXML and select the second option. So this dialog is going to show up, and this is basically where you can change a bunch of settings before you export. Also, this also serves a good first pass where you can check your geometry to make sure they're good before you export to anything. As you can see, this visualization is show you the gbXML file. This other building is also showing up here, but it's just reflecting the architectural background. It's not solid, so it's not really in your file, so you're fine. And and if you go to details, here's where you can check each individual space and see what's in there. You can look at their properties, and also if any of these rooms are problematic, there will be a warning sign at the beginning. So then you can just scroll down to check if all of them are good. Looks like my model is okay. So let's just do next and export this to the project directory. So I'm calling this model broken because I purposefully break this model just to show you guys how to find the issue later and go back to Revit and fix it. Yeah, let me pause and come back here because it's going to take a while to export. Okay, the model is exported to gbXML file, and I have also pulled up IES virtual environment. That is the go-to energy modeling software we use at ZeroNV. So if you're using IESV as well, go to File, Import BIM file, and just pick the file you want to import. All right, so before it completes importing, this dialog shows up, and it's basically, again, where you can change a bunch of settings to choose what you want to import. So this is basically asking you what are the rooms you wanted to import. We definitely need all of them. And here is where all the shading elements are saved. And you can say, check all of them as well because we need all of them. Go to next. I will just click through for the purpose of this demo. But I do wanted to show you this construction glazed. So because these are what I have created in Revit, right? I have created all the glazing in Revit and assigned them to the building. So they are being recognized and being imported, and that's exactly what I want. And then let's go to next and finish. All right, this is the geometry. And I always do one more thing, which is to turn off the inner volume because we don't really need actual like physical wall thickness in the geometry for simulation. We want to find that later when we create a construction. So then here's the model geometry, and you can use this guy to look at the 3D rendering of this model. So that's the 3D rendering of the model. And as you can see, these are all the shading elements I was talking about in Revit. We use the roof to represent them, so they are being correctly recognized in the modeling software. And yeah, and also you notice these are the white portion of each wall is the spandrel panel. And there are also door components in IESVE. But what you will do is create the correct construction and make sure the U factor is reasonable, and that should be it. And here also you can do a visual inspection to see if there's anything weird going on. Sometimes if the issue is big and you will be able to spot them easily. Looks like this model is all right. So let's close that. And then you need to do one other thing, which is let IESVE generate a report for you to show you if there's anything wrong with any of these rooms. Because a visual inspection isn't enough. Sometimes you can recognize issues just by looking at it, right? So let's go to model it, and you can generate a report here. We need everything in this section because it's related to the geometry, and this is going to generate an HTML file for you. So that's the report. And these are all the errors, possible errors you can run into with the geometry. If any of these rooms are problematic, they're going to show up under any of these categories. So we have an issue here, which is this room's got an external hole. So that's what I created purposefully. So let's go to this space and see what's going on. So level 6 residential unit 0611. And a good naming convention can also help a lot when you are trying to identify issue. So we are here, and looks like this is what's giving us a hard time. Let's look at the 3D rendering of it. So yeah, that's the external hole. And this is because this room is not going up all the way to the next floor, right? It's level 6, but it's not going up to level 7. and it's kind of stopped halfway, so it's creating a hole on the ceiling. And let's go to Revit next to fix it. So that's on level 6. You can look at this space, click on this, and look at its property. So everything looks fine to me, except we have a limit offset by 2 feet. So that means it's not going all the way up to level 7. The room is stopped halfway. The height is offset by 2 feet. So we can simply just zero that out. And now this room should be occupying the entire volume. And we will export this model again and import into IESVE, and I will pause and come back later. All right, we have just imported the model into IESVE. I think we can just let it generate the report and see if that error is still there. So nothing here. So we have fixed it. That was a success. Just a quick demo to show you how to find the issue and go back to Revit to fix it. You have like 3 places to check the geometry. One is when you're exporting from Revit, you can check the gbXML file, go through the rooms, see if there are any warning signs, and then you can visually inspect your 3D rendering in IESVE. And then the last step is letting IESVE generate the report. So with all of these 3, you should be able to find all the issues with the model. Yeah, and one last thing I forgot to show you guys is the glazing. So as I mentioned before, we have already assigned glazing in Revit, and I just wanted to show how they're assigned here as well. So go to glazing, and if you look at any of these glazing types, they are what we created in Revit, and they have been imported. And if you pick one, it's going to be highlighted here. So that's basically showing, once you assign them in Revit, and they will be assigned here in the IESVE model as well. The information is saved. So yeah, so that's it. Hopefully this is helpful. When you're firstly starting working on this using Revit to create the geometry, it will be a little bit iterative. You may find a lot of issues and you have to go back to fix things. But once you have done this a couple of times and work on a few projects, and you will really get the hang of it, and it's going to really speed things up, and especially for these bigger ones. So yeah, hopefully this is helpful, and thanks for watching.
Okay, that's it for you and I. So back to you, Stephen, and I think we're hopefully have 10 minutes or so for questions at the end.
All right, thanks, Greg. So it looks like a number of you could not hear that video for some reason or another. I think half could hear it, half could not. So I'm really sorry about that. It must be some glitch with GoToWebinar, but we will be posting a recording of this webinar on YouTube, and it will include the audio for that pre-recorded video. So once again, sorry about that. All right, so it looks like we have around 20 minutes left. I do want to leave some time for Q&A, so I'm going to quickly pass this over to Krishnan. So Krishnan Gowri is a senior consultant and leads the building performance practice team at Intertek. He is also the principal of BIM to BEM Solutions. He has more than 25 years of experience in energy code software development, BIM to BEM interoperability, and building envelope performance assessments. So I'll pass this on to Krishnan now. Krishnan, just be mindful of the time because there are a number of questions which I would like to get to. So
okay, I'll try to be fast.
Krishnan.
Okay, let me see if I can share my screen. Sharing. Do you see my screen yet?
Yes, I do.
Let's make sure. All right. Thank you, Stephen. I'm not sure which screen you guys are seeing. You see my ASHRAE 1810?
Yeah. Yes.
Slide. Okay, perfect. I'll try to be very quick. Already, Stephen read the mouthful of the title for RP 1810. I will use the more understandable name for this project, which is aimed at improving the workflow between BIM to BEM using gbXML. With me on today's webinar is Weili Zhu, who is the principal investigator for this project and did most of the programming work on this. Now, why did we undertake this? We wanted to find a way to create BEM models from BIM without having to go through all of the manual cleaning and other steps. You just witnessed quite a few of them that Chen had to go through to make this work on a very large building. Now, to avoid much of that problems, we wanted to come up with some kind of certification process so that all of the models that are being generated from BIM do not have any manual cleanup work and will be able to generate energy models seamlessly. Now, when we currently look at the models, there are several ways of generating gbXML, and in every which way gbXML is generated, they should all be providing a good energy model. But we know that is not the case, and several industry practitioners reported lots of different workarounds, and then have their own workflows to avoid and save the trouble of cleaning up. Now, I have to first admit that there's a large degree of success in transporting BIM models to BEM in terms of the accuracy of wall areas, window areas, space volumes, and so on. Where we're really running into trouble is that when you have non-standard and non-specific situations of curved walls or different levels of spaces and floors, we suddenly see variations in the way the gbXML is being exported that runs into many of the geometry issues that we see in the energy models. What ASHRAE decided to do was to help the industry by creating some standard test cases so that software developers can really test and make sure that they are producing standard gbXML that can seamlessly be used for energy modeling. What I wanted to highlight is that this RP10 focused on two primary things. One is to create standard test cases, and second is to come up with the web-based validation software. So we'll see how this was done, and I'm going to try to run the entire thing through in the next 5 minutes. In order to identify these 20 or so cases, the RP1810 team took an industry survey and interviews with energy modelers, software developers, and others who are constantly working with gbXML experts, and identified a number of issues that they were encountering in actual projects. Now, these case studies of problems were abstracted and represented in very simple block models of either a single story or a two-story simple box models. Now, in creating these models, what we did was to incorporate one or two changes that will trigger and emulate the actual issues that the practitioners were encountering in their exports. A simple example will be an exterior wall with multiple layers. In some cases, a wall section in Revit might have just 2 layers, such as an exterior insulation finish system, or a rain screen, let's say masonry on steel stud wall system, where you might have the actual wall construction be represented in 10 or more layers. Now, every one of those layers, Revit ends up exporting them to gbXML. Now, whether they are representing the actual thermal properties and whether the geometry of that thick wall section being represented properly in the gbXML is very touchy depending on how the export has happened. In some cases, you will see the exterior layer be represented as a shading surface if the interior boundary is used to export the space volume. So what we did was to come up with a very good set of test cases that are created using Revit models and then a standard gbXML export of the Revit models, along with specific guidance on how the test model should be created and what the details in terms of dimensions, in terms of space properties, material properties, and everything. And we define the expected outcome for the export. Once when this is provided, if the software developers were able to create these test cases and export the gbXML, they can come to the validator and verify that the validation criteria is met or not. And the validation criteria are as simple as taking the space counts, space areas, volumes, surface counts, and if there are going to be thermal properties, then we will be verifying those as well. A total of, I think, 20 test cases is what we had. Let me get to this. Are you able to see my screen still?
Yes.
Okay, so this one, if you look at it, we have a total of 20 test cases. Now, this is available in the online validator, which Willie will shortly demonstrate. Now, each one of these test cases has a particular aspect that is being tested. And the first one we were talking about is the test one is about the exterior wall with multiple layers.
Hey, Krishnan, we can't see the test cases. You're on some other slide.
Okay, just make sure. Okay, are you seeing that now?
Yes, test case 1, exterior wall, multiple layers.
Okay, sorry about that. Okay, so I was flipping through this. So there's about 19 test cases that are currently available on the validator. And I was going to quickly show you what the test case 1 consists of. And this test case 1 is trying to test the exterior walls that are consisting of multiple layers. And what this test case description provides is how the test case should be created, what the assembly details are, the wall system, the exterior insulation finish system, and the rain screen system. And here is the layout of the model for this test case. Once then this test case is created, the software developer can export the gbXML for this test case and then upload the gbXML test case here to get validation reports. I'm going to let Willie walk through this whole process, but before I hand off the demo to Willie, I wanted to highlight this gbXML level 1 certification. Now, what this one allows is for anyone with a gbXML to upload their model and then validate and view it validate and view it using the viewer that is available in here. So this is just a simple test case that I uploaded here for viewing. But in this viewer, you can get to explore each and every aspect of the space and the surfaces that are present in this model. Now, you don't have to be a software developer. You could be just a gbXML, or at least an energy modeler exporting gbXML from some software tool. You could drop that gbXML here and view it and then validate whether this geometry is correct or not. Now, this will save some bit of time that we saw in the previous presentation where the Revit export was brought into IES to view the model. This can eliminate that step to a certain extent, I should say. And I think there is a lot of value in this for all users that are attending the webinar today. So you can create an account and then start exploring your model using this validation step 1. And I think I'll stop here. Stephen, if you don't mind.
Yeah, I'll pass it on to Whaley.
Yeah, thank you.
And Whaley, just be mindful of the time. We have about 7 minutes. I did want to leave some time for Q&A. So we may go over a little bit. However, what I will do is that for any questions that are not answered during the webinar, I'll make sure to forward these questions to the appropriate people, and we will answer them offline. We have record of everyone who's asked a question, what the question was, and your email. So we will get to your questions even afterwards. So Whaley, like I said, if you can be mindful of the time, so we at least have a couple minutes to answer some questions. Thanks.
Okay, got it. Thanks, Stephen. Thanks, Krishnan. Hi, everyone. My name is Whaley. I am the product manager and the developer of this new gbXML validator platform. I think Krishnan already covered most of the backgrounds of the research work. So here I'll just dive right in. Right now, we are seeing the landing page of this platform. At the left side is a navigator, and currently it only has a dashboard. Upper right corner, once you have the account, you can change your profile information and reset password. The main focus here today is the dashboard, where the left side shows the information of the account, and the right side shows the softwares that you are using for the gbXML compliance testing. So you can have added multiple different softwares like what we have here. We have this software called BEM port that exports the gbXML. We have different versions, so we create a different software here. So click the button add. You can add this. For example, if I want to add a new version to it, we are working on the 1.3. So you can add this new software using this add button. And the thing, I'll put the logo on it. Click save, and then there's this new BEM port software will be listed for the gbXML compliance test. There are 2 levels of testing. I think Krishnan covers most of the function of the level 1 certification. But one thing I wanted to mention is it doesn't. We don't have to get the level 1 certification passed in order to get level 2. So if you wanted to directly start at level 2, you can just click the validate. Once you click validate, you can see a list of the cards here that shows each card represents a test case. I'll just quickly go through. First of all, we wanted to test the test 1 case. The next page will show you a step-by-step instruction for the test case creation. Follow this guideline to create the test model in your BIM software, and then export it to the gbXML. Once you have the gbXML model, you can click the upload gbXML test case. In here, I'll just upload the test 1 model that I have created before. Click upload. And we'll automatically enter this interface, the viewer. The purpose of this viewer is to examine whether you upload the correct model, or also you can check whether this model has any flaws or issues before you starting the testing. After the verification, visual verification, you can click the start testing. So within a second, the test engine already give us the results, and the results shows we have passed the test case 1. So once you enter this phase, that means you already complete the test case. You can just click return to test case list. And note that once you successfully finish a test case, the test case, the card will be highlighted in green. That means this test case is passed. Let me try another test case to show you more functions. The test case 10 is an atrium space or high ceiling space. So let's dive in this case. Similarly, you follow the instruction to create the model and then upload the gbXML test case. In this test case, I'll create a model that is purposely had some flaws to demonstrate the failure case and show how to use the platform to do some debugging. So here again, verify that there's no problem in the geometry. We click start testing. So this model we instantly receive error message. But don't worry, we do have a few debugging features built into this platform. First is another visual verification. So you see here has a model switch. So currently it highlights the submitted model. You can switch to reference model as well to see to examine whether there's any discrepancies in terms of the geometry between these two models. The second tool you can use is display result details. In here, it lists all the validation rules we applied for the testing. The highlights shows the failures. Click the failure and also click the element. You will highlight the element that has failed the test. So another function we can use is download result report. This is the HTML report. There is another more detailed version, error log, will give you more information about the testing. So there are 2 reports you can download for the debugging as well. Once everything is fixed, you can click upload again and upload gbXML test case. And retest it and pass the test case here. That will be most of it. Once you finish some test, you decide, okay, I'm done today. You can leave the platform and it shows you the progress of the certification, and you can close it and come back next day. You will be still starting with the current progress. So I think that covers most of the functions on the platform. We'll work on any testing, any more like test people come to the platform and do the testing on the platform. Okay.
That's fast as we could do, Stephen.
All right, thanks, Krishnan and Whaley. So it's at the top of the hour. However, we didn't get to any of the questions, and there actually are a lot of questions. So what I'm going to do is this. Why don't we answer a couple questions for the next couple minutes? And what I'm going to do afterwards is I'm going to forward these questions to the panelists. We're going to answer them, and I actually will post them probably on the gbxml.org website, and I'll make sure to send a link to everyone so we do get answers to these questions, because there's a lot of them, which is great. So why don't we start with a couple here? And one of them is actually geared toward Greg. This is asked by Josh Roth, no relation. Are any of the tools that Zero NV has developed for IES, as well as the external validator, available for public use, or are they proprietary?
Great question. Right now, everything is being used for our own internal use. We are interested in, like, IES as a content store, so we're interested in potentially uploading things there. And we're working on means to be able to share these tools, but don't have anything set up now. So I guess the best thing to do would be shoot me an email, let me know you're interested. And then I can keep you posted once we have a way to access them.
Great. Another question regarding Revit to IES gbXML workflow. Have you had success importing building geometry that has non-vertical, angled, or curvy walls?
Yes, we've had slant non-vertical walls. Yes, at some point you need to switch it to a roof. And probably Stephen and Krishnan may know more of the details. We just kind of like try it until it works and don't dig into why. Curves, you would need to break it. Like if you have a round surface, you need to break it into several straight flat elements in order to get that to work. So there, you know, in anything, there's simplification that needs to happen, but there are ways to do it.
Cool. Here's a question from IES, actually. Has the Zero NV team used the new IES Dynamo plugin for Revit that allows export of gbXML Plus, including HVAC systems data for import into IES VE?
No, we haven't used that.
Okay, sounds like something very interesting. Let's do a couple more here, and then we will end the webinar. And like I said, we will address all these questions after the fact. Let's see here. The idea of the validator is to test the quality of gbXML generated from a BIM authoring tool. Is that correct?
That's correct, yeah.
Yes.
It's also, I think we are trying to get all of the gbXML authoring tools to, you know, validate themselves using this validator so that the gbXML is standardized enough that all software can use the generated gbXML. Yes.
Okay. Here's a question for Greg. The Revit model which is created is based on the IES BIM navigator steps, or let's see, or do you have you developed some methodology based on your experience? You understand that question?
This might be a better question for you. The BIM navigator in VE is newer, and so you've been able to just like click the file menu, import BIM. It used to be import gbXML. So they've been adding tools, and I'm not sure how many of those you was using, but I think he showed the the HTML report that pops up after the import is done. Hopefully that answers the question.
Good. Here's a question I've been getting now a couple of times. Generally speaking, what are the differences between gbXML and IFC? So I've been asked this question for 10 years now. And so I'll answer this. So IFC are industry foundation classes, mainly used in Europe, not used in the US, but very popular in the EU. So, IFC, for example, Revit, you can save as IFC. It will save the entire architectural model in IFC, and then you can import it into, your other favorite BIM authoring tool. gbXML is solely focused on the thermal model. So we are focused only on the properties of the building that allow you to perform analysis on it. So you may think that IFC has an advantage over gbXML. Well, each has its own advantage. It depends on what your workflow is and what your goal is. gbXML is really good at getting that data that is specific for building energy modeling from Revit into your favorite building energy modeling tool. IFC has other advantages. So, we could have a whole webinar on this alone, but I just did want to bring up that one question. All right, so why don't we do one more question? I know we're over, and like I said, we will be posting a recording of this webinar and also answering the remaining questions that we don't get to today. So let's see here. I think this is actually for you, Greg. So as the energy modeler, are you building the Revit model in parallel? Typically, the mechanical engineer is receiving the architectural Revit model from the architect.
Yeah, we're rebuilding it. I've tried a bunch of times, and I've seen lots of other people try, and I'm sure there are ways to, like, if you're an architecture firm or an integrated architectural engineering firm, that's a great use case to like build the architectural model, maybe following some of the important rules so that it could translate better. I'm sure people are doing that, but for us, we work with, lots of different architects, like every project, in the way each firm builds their model, builds their constructions. You know, each construction can be set to room bounding or not. So it's just very inconsistent if we go in and try and like edit the architectural model so that it can export in a clean way. So we've just, it's fast, it's consistent for us to basically link in the architect's model and we trace it. There are ways to copy some stuff over, and there's like space naming utilities that can like automatically import all the architect's room names as space names and things like that. But for us, it's like if you have a third wall and it's modeled as one wall with like additional layers, or it's two different walls, or if you have a column and you know there's a space that gets dropped inside, all that kind of stuff, it becomes really cumbersome and hard to fix. So we build our own, and that's, you know, it's redundant, but it's faster than all of the consistent, reliable alternatives in our opinion.
Okay. And one final question. If it's needed, and this is for Greg again, if it's needed, do you assign context like the tall building next to the 27-story residential building in the demo with some specific property for it to be recognized as an adjacent building when imported into IESVE?
Yeah, that's a great question. I would model it as one big room, one big tall room, and then it'll come in as a space, probably a normal space, but you could just select all those spaces in VE and in the model it application, and then you just switch the properties to an adjacent building there. So we've done that. That's easy to do, and it's, you know, it comes down to personal preference in what kind of model you're building, and you know whether you want that in your model. But definitely easy to do, and that would be like another kind of powerful way to leverage this workflow for sure.
And
All
you
right,
export
great.
it as a mass, that's all.
Yes.
Okay.
All right, so we've actually gone 10 minutes over, so I would like to end the webinar now. Like I mentioned, I will be sending out a link to everyone who attended with a link to the recorded webinar. In addition, we will be answering the remaining questions and posting those answers on gbxml.org. So thank you so much to all the panelists. Hopefully this was very informative to all of you, and hopefully we will see you again soon at our next webinar. So once again, thanks so much.
Yep. Thank you, Stephen. Bye.
Yep.
Thank you, Steve.
Great day, everyone.
Bye-bye.
Thanks everybody. Thanks, Stephen.